Hello everyone, this is Levanyan, and today I'm presenting to you the automated field irrigation solution. There are 4 points on the agenda. The first one is the technical diagram of the components comprising the automated irrigation system. The second one is how it is possible to connect the automated irrigation system to our cloud platform. In the bullets 3 and 4 we will have a look at the work screens of the SCADA system and the operator's color touch panel. On the left hand side we have the field irrigation controllers with the tailored embedded software and the sensors that are connected to those controllers. The sensors are used to gauge the pH of the soil, the humidity level of the soil, and the temperature of the soil. So these 3 parameters are measured by the irrigation controllers, and the embedded software in the irrigation controllers processes these data and sends further to the centralized system. The second one is the LoRaWAN to Internet Wireless Gateway. It is used to capture data from the irrigation field controllers, process that information, and send further to the higher order system. It works both ways. It contains the routing table for the irrigation field controllers, and the software in the LoRaWAN gateway, whenever it receives information that has to be stored in the irrigation field controllers, such as any configuration parameter, it knows which exactly device has to be spoken to, and for that matter it uses the SAD routing table. The next one is the control unit of the pump station, which comprises 3 elements. The first one is the industrial PLC, programmable logic controller, which runs the software that controls the work of the connected pumps, and in its work it uses such parameters as the work schedule for the irrigation system, as well as the parameters that have to be kept, such as the pressure in the pipeline and the level in the reservoir. The second element in the pump station control unit is the human machine interface touch panel, with the software that allows to manage the pump station manually. So whenever you need to switch from the automatic mode to the manual mode, you use the control panel and then you can switch back. This human machine interface touch panel also visualizes the current operating data of the pump station, such as the immediate electricity consumption, the current passing through the lines, and the voltages on each phase. Alright. The third one is the protocol conversion gateway module, which accepts data from both the pump station and the field controllers. The field controllers send information through the LoRaWAN internet gateway, and that information is passed through the protocol conversion device. Alright, and then it repacks this information into the data model suitable for the higher order SCADA system. Now we're coming to the most important element, which is the SCADA system. The SCADA system is installed on a PC. It embodies all the functions required to configure every element in the system, each irrigation controller, the pump station controller, and archive data received from those devices. So basically this is the control center of the irrigation system. Let's now have a look at how information is exchanged between system components. When measurements are taken from the sensors, this data is quantized by the field irrigation controllers, packed up into LoRaWAN packages, is sent across the wireless link to the LoRaWAN to Internet gateway. The LoRaWAN to Internet gateway identifies the senders using the routing table and repacks this information to be sent further to the protocol conversion device. The protocol conversion unit is a multi-purpose device that is primarily used to exchange information between the field irrigation controllers through the LoRaWAN gateway and the SCADA system, and between the SCADA system and the control unit. So the protocol conversion module, what it does, it buffers the data in both directions. It also accepts data coming from other auxiliary devices, such as the electricity meter that is installed in the pump station control unit, and submits that information in all directions depending on the current sequence. In the opposite direction, when the SCADA system needs to configure a device, then it submits information to the protocol conversion unit that, depending on whether it is a field irrigation controller or the pump station controller, it will repack information into the protocol required and will direct these information packages either towards the control unit or towards the LoRaWAN gateway, which will direct information to the required field irrigation controllers according to its routing table. I must also admit that there are certain peculiarities pertaining to the exchange protocol between the LoRaWAN gateway and the field irrigation controllers, which is that the LoRaWAN gateway is capable of pushing information towards any irrigation controller only in response to a package coming from the irrigation controller itself. And then there is a certain delay that is imposed by the LoRaWAN protocol between data submissions from a single device. So that being said, it means that LoRaWAN gateway also performs the buffering function for the data packages traversing from the SCADA system towards the field irrigation controllers. Alright, so that was the overview of the components comprising the system, and now let us make a separate list of software components only. This step should allow us to comprehend the overall complexity of the system. Alright, so what we have on the list is basically 6 major software components. The first one being the embedded software contained in the irrigation controllers that takes the measurements and do scheduled irrigation by controlling the valves. The second one is the message processing and routing software in the LoRaWAN gateway, the one that instantiates the reception of data from the irrigation controllers, packing into a different protocol, buffering of data coming in the other direction to the irrigation controllers, and knowing all the basic routing. The third one is the instance of software in the industrial PLC, the one that knows all the logic pertaining to the management of irrigation pumps, and it knows how to work with the connected sensors. The fourth one is the software in the human-machine interface, which is the color touch panel that is in the pump station control unit. The fifth one is the software in the protocol conversion module, the one that I've already described previously, and the SCADA control system software, which is the primary logic unit that manages the whole irrigation system. Alright, so let's move on to the next slide, which is the description of how to connect to the cloud system. Before we continue, we have to determine what information needs to be stored in the cloud system in order to be able to accommodate data coming from the irrigation system. The cloud system sits on top of 2 databases. The first database is used to maintain models of devices along with their parameters belonging to those devices. The second database is used to keep the values coming from the modeled and instantiated devices. The 2 databases you can see close to the center of the slide. So the first step to solve the task of connecting the irrigation system to the cloud platform, as you may now understand, would be the modeling of the irrigation devices and the pump station control unit in the cloud system. We can also model such devices as irrigation pumps, but we would only be able to provide the energy consumption data for those devices, so the secondary parameters only. Okay, so following this logic, we're going to be able to gather information from our SCADA system as from any other system when we have created the models for our devices. After the modeling process is over, we will have to set up submitting of information from the SCADA system to the cloud platform. And this is where we will use the protocol conversion unit that is part of the irrigation control system. The only concern that may be is the breadth of the transmission channel, since it will be used to submit information from a good couple of tens of devices simultaneously. If there is a requirement to connect further hardware or third-party systems to the cloud platform, that can as well be achieved. We already have experience of connecting a third-party billing system. In this case, that was the billing system called Metro Billing, provided by Porter One, and we have fully integrated with this billing system, and we are collecting information online and presenting that in our cloud platform. In this case, the cloud platform contains virtual devices that we have modeled, and those devices are mapped to the data received in the billing system. And at last, you can model data for further visualization on mobile devices in the application called Metering App. The full name of Metering App is Metering Application, and it is an Android-based application developed by our company, and the specialization of the application is to depict data from the cloud platform. Alright, and here is some arbitrary chart on data from a hydrometer registered in our system. On these charts you can see two graphs combined. The first one is the blue bars representing hourly consumption, and the green one is the total consumption of water that is measured by the hydrometer. Alright, so I think we are done with the slides, and now let's move on to the sample live screens of the SCADA system and the color touch panel of the operator of the pump station. Alright, so the first thing that we see are the two buttons that lead us to two distinct parts of the system. We are choosing a valid user profile, otherwise the system won't allow us to change settings for anything. The guest login is for viewing only. Now we've got to set the date. This date will be propagated to all the devices in the system, and we're gonna go ahead to the settings of the watering system. On the first run, we've got to tie up the field irrigation controllers to the plots of land. Here we call them areas. The controllers are identified by their MAC addresses. Underneath the settings for areas is the IP address setting for the LoRaWAN gateway device. Alright, and we are moving ahead to the page of plot monitoring. On the page you can see measurement data for 6 areas. Please note that we don't have sensors connected to all the irrigation controllers at the demo time. Now we're proceeding to the page with the configuration of the schedule of watering for a particular plot of land. On this page you are able to operate the valves manually or set them to the automatic mode, as well as set up the schedule for the watering of the plot of land. For this matter you have 10 profiles that will operate across the 24 hours period. And on the right hand side of the page you can set up particularities on how valves should be operated by the controller. Alright. Now we're going to set the second sector valve in the open state manually and go ahead to the monitoring page. On this page we see that for the second area the two valves are opened. The first one because of the schedule, and the second one because of the manual mode, and we, if you remember, opened it manually. And now let us go ahead and open up the system log for the watering system. We see a lot of red, and these messages indicate that we almost don't have any sensors connected to our controllers, just the controllers without sensors. We have sensors connected only for one area. And now let us move forward to the pump station control part of our system. On the left hand side of this screen you can see electricity consumption parameters, and those parameters are gauged by the installed electricity meter. On the right hand side you can see the reservoir filling level. Again, this is sample data. You may think that the current readings from the electricity meter are a little bit strange, but this is how we have modeled this data in our office, using the single phase connection to the electricity that we have there. On this page you can also see the switches that allow you to switch on and off the pumps manually when in manual mode, or set the control logic to the automatic mode. Also, the monitoring parameters for the motor hours for each pump and the current pressure in the pipeline are depicted there. On the following page you can set up the parameters that the PLC in the pump station control unit will maintain, and those parameters are the minimum pressure, the maximum pressure in the pipeline, and the level in the reservoir. The alarm settings pane is the settings for the situations when the PLC will work without a current connection to the SCADA system, so it will be standalone. Alright, and now you can see the page where you can define the timetable for work of the pumps. So if you define values here, they will only work during the defined time periods and only in the hours defined there. And also you can define the normal schedule and the alarm schedule. Again, the alarm schedule is the one that will be executed when there is no SCADA system, and the PLC in the pump station control is in the standalone mode. And needless to say that the pump station control unit has its own alarm page in the SCADA system. It is more or less the same with the one that you already saw. And now we're steadily coming to the question of the operator panel. It more or less resembles the work screens that you already saw in the SCADA system. They are a little bit different in a way because the screen size of the operator panel is different, but the parameters are the same. So thank you very much for watching, and send me your questions if you have any. Have a good day.